Hey guys, so I know I sent you out that Poisson distribution video. This one's going to be on binomial distribution, and this one's a little bit more in-depth than Poisson. So, binomial distribution. And the equation for binomial distribution is going to be P of x equals combination n over x times p to the x power times 1 minus p to the power of n minus x. Now, one thing that you'll need to know for binomial is how to do a combination. There is a function on your calculators on how to do a combination, and I do plan on holding a how to use your calculator with statistics course. I will be doing that probably in a video. It might be easier, but here I'm just going to be very brief about it. In a combination, you have n on top and x on bottom, and what the n stands for is the number in the sample. And what x stands for is the number of times something happens, or the number out of the sample that we are concerned about. Alright, so when you're doing n combination x, it's not n divided by x. When you're doing that, I'm trying to find the page in the book on combinations and how to do these. On page 125, it gives a good formula for it. The formula for a combination is going to be n factorial divided by x factorial times n minus x factorial. And what factorial means is if I were to say that my n equals 10, and that has to be factorial, that would be the same thing as saying 10 times 9 times 8 times 7 times 6, all the way until you get down to 1. It does not include 0 because 0 is just going to cancel out everything that we had for the factorial. So if we were to say that we have, let's think of a combination. Let's use 10. So if we were to find 10 combination 5, that would be the same thing as saying, okay, 10 factorial is 10 times 9 times 8 times 7 times 6, all the way down to 1, over, and my x is 5, so 5 factorial, and then my n minus my x, well, 10 minus 5 is going to be 5, and this is also a factorial. And it's the same thing for any numbers. If I had 11 factorial, I'd take 11 times 10 times 9 all the way down to 1. So that's what that exclamation point means. There is a function in your calculators. It's called the NCR function, and that's going to be under your probability button on your calculators. I'm pulling out my TI-84 Plus. If you do have a TI-84 Plus, what you're going to do is you're going to type in that top number first. So you're going to type in 10, and then you're going to go over to the math button, and you'll go over to probabilities, P-R-O-B, and on number 3 you'll see NCR. It's right below NPR, and I want you to remember that we're not looking for NPR because that's finding the probability. We're doing NCR, we're doing a combination. So I hit enter on that combination function, and now it's telling me to enter another number, and that's where our x goes, our 5. So when I do 10 combination 5, I get 252. What this 252 means is that out of 10 for our n, let's say that we're talking about pairs of shoes to buy at DSW. out of 10 total number of types of shoes that you can buy, and if we're buying 5 pairs of shoes randomly, there are 252 ways that I can select shoes from that sample of 10 pairs of shoes. So going back to the binomial distribution problem, at n and x, n over x is actually n combination x. And we're going to come over here, and we'll actually go through a problem. I feel like that's the best way to explain exactly how to do binomial distribution. And in your book, binomial distribution is going to be in chapter 5. It's after Bernoulli's on page 141. And we're actually going to go to page 142. And we're going to do example 5.7 together. So example 5.7 says that a company that transports tourists to a wildlife resort deliberately overbooks its buses because it knows from previous experience that only 75% of passengers turn up. So again, like I mentioned in my Poisson video, what you're going to want to do is try to pick out whatever information you think is important from the problem. So I think that 75% of customers that show up is important. And what I can do is take that 75% and convert it to a proportion. So I'm going to say 75% is equivalent to 0.75. And reading on, it says for a particular stop for which she normally reserves 10 seats, she books 13 passengers. So she has 10 seats available. And she books 13 passengers. So when we're looking at the first problem, we're looking at I. It says, what is the probability that all 10 seats will be occupied? Well, there are certain variables in this equation that I'm going to have to find before I can start plugging in my x values. And we have established the equation for binomial distribution. So let's just start writing out variables. So we have to know n. X is interchangeable, remember. So we're going to plug values in for x. We're going to have to know p, the proportion. And we're going to have to know 1 minus p. Now if you're going through this problem and you're wondering, okay, well, what is going to be my n? Because it tells me 10 seats are available and there are 13 passengers. The question is asking about the 10 seats that will be occupied, but the 13 passengers are actually going to be our n. Because we're talking about what percent of people are going to be showing up and not what percent of seats are going to be filled. So n is going to be 13. That's why it's so important to read those problems very carefully. So n would be the 13 passengers booked. Because remember, she's calling these 13 people and she's booking 13 for the 10 seats that are available. Now our P is going to be fairly easy to find because it's going to be the only percentage or proportion that they give you in the problem. So for this one, it's actually given to us as a percentage, but P is going to be the proportion of people that actually show up, which is 0.75, or 75% of people show up after they've booked a ride. And 1 minus P is actually doing exactly what it says. We're just going to take 1 minus 0.75, and we're going to get 0.25. So now that we've gone and we've found all of these variables, we can actually plug them into our equation. I'm just going to do it right here so I can still see them. We're going to say that the probability of X happening equals our N up here, which is going to be 13. I'm going to erase that line because I don't want anybody to think that we're dividing. This is a combination, like we talked about earlier on in the problem. Over X times our P, which is 0.75, to the power of our X, times our 1 minus P, which we found to be 0.25, times our N, which is 13, minus our X. So now that we've got that equation done, you'll notice that it looks kind of like a Poisson distribution equation where the x's right here are still interchangeable. We're going to plug in a value that they're asking us about in these x spots right here, here, and here. So now let's read the problem, I. And I is asking us what the probability is that all 10 seats will be occupied. All 10 seats. And this one is fairly easy. They're giving us 10. And so all they're concerned about is that the 10 seats are filled. And this 10 is going to be our x. So we can do the same thing that we did with Poisson. We can take that 10 and we can plug it in here, here, and here. And we can follow the steps of the equation to solve for the probability that all 10 seats will be filled. So we're going to say P of X equals 13 combination 10. And what I'm doing here is I'm putting 10 wherever X is in the equation. 0.75 to the power of 10 times 0.25. And this one was a little bit funny. It's to the power of 13 minus X. So we're going to say, what's 13 minus 10? Because 10 is our X. And it's going to be 3. I'm going to plug all of this into the calculator. And again, I just want to stress how you use your calculator is very important. Your calculator is actually very stupid. So you're going to want to do this first, and then move on to this portion, and then move on to this portion. And then you're just going to multiply these three together. But if you were to plug all of these in together, your calculator is going to give you an answer that's very far off from the correct answer. On the exams that Professor Onya hands out, I know your first one is going to be coming up at the end of February here. One of the biggest mistakes that I do see on the exams are people who do all the work correctly and get the answer wrong because they're using their calculators wrong and trying to overwhelm it with all of these functions. So just be very mindful of how you're using your calculator and making sure that you're breaking everything down really well. So now when we plugged all of that in and into our calculator, we get 0.25165. What this number means, and remember that we were solving for P of X right here. So what this number means is this is the probability that out of the 13 people that this lady calls to book rides for, the probability of all 10 seats being filled is going to be 0.25 or 25% only. So now what we're going to do is we're going to move on to II. And what II wants to know is what is the probability that only 60% of the reserved seats are occupied? So only 60% occupied. One key word in here is that they mention seats. So here, what they're concerned about are how many seats are going to be occupied by people. So I know some people are going to think that the probability is going to be 0.6 here, and we're going to switch that out. We are actually going to keep the probability at 0.75 because it's still only a 75% chance that people are going to show up for their ride. So we're going to do this and say P of X equals N, which is going to stay at 13, because remember, we still are calling 13 people to reserve rides, over X times P, which stays at 0.75, because it's still only 75% of people showing up for their rides, to the power of X, times 1 minus P, which is still 0.25, because remember, P hasn't changed, times N to the X. So up here we're going to say to the power of 13 minus X. And now it's still the same equation, but I don't know what I want to plug in for X. So we're going to say, okay, we have 10 seats that we're trying to fill. And it's asking me, okay, if 60% of the occupied seats show up. So I can say, okay, what's 60% of 10? So 10, oops. So 10 times 0.6 for 60% is going to be 6 seats. So what we're doing here, the reason why we're taking 10 and multiplying it by 0.6 is what this question is asking is, if 60% of the seats are occupied, what's the probability that only 60% of the seats are going to be occupied? So here we've got 10 times 0.6. We got 6 seats that are going to be occupied. And that 6 is actually going to be our X value. So we can take that over here. And say, okay, P of X equals 13 combination 6. I'm plugging 6 in wherever there was an X, times 0.75 to the power of 6, which is our X, times 1 minus P, or 0.25, to the power of N minus X. And 13 minus 6 is going to be 7. So we can just say 25 to the power of 7. And when I've done all of this math, I can say that 0.01864, I'm sorry, 0.01864 is going to be the probability that out of the 75% of people that show up for a ride, that 60% of the seats are going to be occupied. So that's the 0.01864. And now, sorry if I'm making you guys a little bit dizzy. Now when I come over here, we're going to solve for I. Find a different color that I haven't used. So when I'm looking at I, it's saying, what is the probability that they would have to pay compensation to some passengers for not finding space for them? So when you're thinking about what that means, think to yourself, when would you have to compensate somebody for not having enough seats? If you booked more than there were seats, right? So if we got 10 seats, but we're booking 13 people, and we're thinking, okay, when would I have to compensate people? I would have to compensate if there were 11 people that showed up, 12 people that showed up, and 13 people that showed up. If it were 11, I'd have to compensate 1, I'd have to compensate 2 for 12, and 3 for 13. So down here, I'm going to say, okay, what are my x values? Because my equation doesn't change, remember. The only thing that's going to change throughout this are my x values. And my x values are going to be the 11, the 12, and the 13. So now that I've established my x values, all I have to do is write down that same equation, that p of x equals 13 combination x times 0.75 to the power of x times 1 minus p, 0.25, to the power of n minus x, or 13 minus x. And since we've established that our x's are 11, 12, and 13, we can plug those into the equation. So this one would be 13 combination 11, 13 combination 12, and 13 combination, not divided by, 13 combination 13. And it's the same up here. So here I'm just going to take that 0.75 to the power of 11 times 0.25 to the power of 13 minus 11. I'm going to do that 0.75 to the power of 12 times 0.25 to the power of 13 minus 12. And here it's going to be that 0.75 to the power of 13 times 0.25 to the power of 13 minus 13. I'm not going to sit here and figure out the math, but I am going to go down here. I'm going to write down the answers, because this one, what we do here, is going to be similar to what we did in that Poisson distribution problem as well. So for the probability of having 11, what we got was 0.205896. For 12, we got 0.102948. And for 13, we got 0.02 37573. Now, this is a similar thought process to what we talked about for the Poisson video, where when we're going to do addition, we're looking for OR, and multiplication, we're looking for AND. So for this problem, I can't have 11 and 12 and 13 people show up, but I can have 11 or 12 or 13 people show up for me to have to compensate. So what that tells me is that I'm going to be adding, because here it says when there's OR, I'm adding. So when I add all of those together, I get 0.33206012. And so what this answer means is that there's a 0.33, let's round it up and say that it's 0.333. There's a 0.333 or 33% chance that I'm going to have more than 10 people show up, and I'm going to have to compensate some people. So with this, I'm trying to find where I started off here. So this is one way that we're able to do a binomial distribution problem. Solving other problems is going to be very similar. One thing to look for, let's just make a list on what to look for if it's a binomial distribution problem. So if it's binomial, they're going to give you either a probability, a percentage, or a way to find the probability or percentage. And remember that to find a percentage or a probability, we are taking our n, or excuse me, we're taking our x divided by our n. This is similar to a combination, but in a combination, remember we have n on top and x on the bottom, and we aren't dividing, we're plugging it into our calculators. For this, we're just taking x number of times something happened out of n, our sample size. So when we take x divided by n, we get a probability that we can convert into a percentage. And that's what we're going to be able to use for binomial distribution. So if I were to reword this problem and say that out of 100 people, out of 100 people that they book for these rides, booked for rides, 75 people show up. And I can take that and look up here and say, okay, I can find the probability with this information. I know that my n, my sample, is 100 people booked for rides, and my x is the 75 people that show up. So I can say, okay, what's 75 divided by 100 is 0.75, or 75%. It would have gotten us to the same place as the information that we had to work with. It was just a different way of giving us that information. I will go through and post another walkthrough with a different problem on binomial distribution. This one was a pretty basic problem. Let me know if you have any questions. You can also contact Sarah or Claire or Shook Yang and let us know, but we want to make sure that y'all stay up to date on all of this information. This is definitely a very important portion in our class, and stuff is starting to get a little bit more difficult with the equations, so remember to get help if you're not understanding something. Have a good night.